This one is interesting because plants like this used to live across Europe and across the world, and they find bits of it trapped in amber, a bit like Jurassic Park style things. But now they're isolated in some very small pockets in South Africa, the only place that this plant lives. It's interesting, it has sticky leaves to trap insects, but the stickiness here is entirely non-aqueous. So physicists, as a sort of physicist with an interest in soft matter, this is interesting to me because there's a little tiny plant next to it which has become the dominant carnivorous plant that lives in the same area. This has a water-based glue which dissolves its prey. So this thing has a resin-based glue, it's not water-soluble. And it turns out that this is less successful than the little water-based guy at the bottom. This is why this guy's been pushed back to a tiny corner. But my background in thermodynamics as well came in because this plant is rare and it's difficult to grow as well. The seeds are very difficult to germinate. It was almost impossible to germinate it. I kept this thing in a pot for about 6 months to a year, nothing happened. And then I went to a talk down in Kew Gardens a few months ago. I saw a talk by an Australian who was talking about the importance of fire in the ecosystem. So I took this pot which had a seed growing, you can see a seedling growing in it now, and I put it next to a bonfire and it actually got hot enough to melt the pot a little bit. And the whole of the top of the soil was scorched. And within about 2 or 3 days later, the seed germinated. So it's really interesting to see the way that conditions that we think of as extremely hostile, a plant sees as fortuitous in some ways. And it actually relies on fire, relies on these hostile conditions to wipe out all of its competitors. And suddenly it can shoot up. So even temperatures of sort of 80, 100 degrees, it's quite happy. That's its signal to start growing. This is my sort of statistical physics plant, if you like. I'm going to just pop it out of its pot. And what you can hopefully see inside there, there's some thin filamentous roots. They're not actually roots. Biologists say that these are underground leaves, but I'm not quite sure what the distinction is. They're hollow tubes. Microorganisms can swim into these things, but they can't swim out because they've got microscopic structures inside. And it's interesting to look at the design. I've got to be careful using the word design a little bit when talking about biology. But if you look at the shape of the internal structures in here, we can see how the plant has evolved to guide microorganisms inside it to a little stomach chamber which exists up by the top and by the leaves. This is an example of using a physics technique to study a biological structure. We use scanning electron microscopy to look at the cutaway of this root. And if you look inside it, you can see that there are hair-like structures, and the stomach of the plant is up at the top of the picture, and the slit that microorganisms can swim in through is kind of at the bottom right-hand corner of the picture. And we can see how these little hair-like structures act almost like a lobster pot and trap microorganisms. In fact, there are rows of these all the way up the inside of this tube, and that's how the plant guides its prey to its doom, and it leads directly to the stomach where the plant can digest the organisms and take the nutrients. Oh, the name of the plant is Biblis gigantea. It's a rainbow plant is the common name for these things. And it's got insects that live on the leaves, and the insects have evolved to not be caught by the leaves, which is an interesting trick of physics. It's to do with the surface coatings and the hairs, and the hydrophobicity is the word that physicists use. But anyway, the plant captures other insects that live in the environment, and as soon as the insects get stuck to the leaves, these little predator bugs shoot up the leaves, not being caught by the sticky bits, and eat the prey straight away, and they help to pre-digest the prey and provide nutrients to the plant that way. Kind of an interesting one from a thermal physics point of view. You tell me if you think it's interesting or not.
It will be, I'm sure.